Here we go. And Eryx Cooperativa de Trabajo, Partner Business Development. So thank you very much for your time, Manuel. Please come up on stage, and it's all yours.
Thank you. Hello, everybody. Is this? Yes. Hello, everybody. And first of all, thank you for being here. A few disclaimers. My original background is computer science, so I usually get very technical when I talk, but that's not going to be the case today. And the second disclaimer is that I'm not actually going to talk about the future. And I don't want to be disrespectful with the title of this beautiful event. I'm here today to tell you a story about the past, about the recent past, that I believe might help us move forward better. Because those who forget the past are doomed to basically repeat it, right? Unlike all stories, this one begins with once upon a time. There were two people that wanted to communicate securely through an insecure channel, Alice and Bob. And for thousands of years, since Julius Caesar to the last World War, we humans have been using cipher systems to basically do that, to securely communicate through an insecure channel. And throughout all those years, I'm saying here 1,000, we've been using different cipher systems that have one thing in common. Both Alice and Bob needed to share a secret in order to encrypt and decrypt those messages. So the question was, how could Alice and Bob have this shared secret if they are trying to communicate through an insecure channel? Obviously, sharing that shared secret through the insecure channel was not a good idea. So how can we do that? For all that time, there was only one solution. You had to create a separate secure channel and share the secret there. Time went by, years and years and years, until in 1976, there was a groundbreaking discovery. Some scientists in the US came up with a paper and published the RSA algorithm. It was the first algorithm to implement asymmetric cryptography. In this kind of technologies, of cryptography technologies, you didn't need that shared secret. There was no need for a different secure channel. RSA technology, asymmetric technology, enabled for the very first time to encrypt a message that could only be decrypted by one particular person. And you only needed the public key of that person. One sec. Yes. So nowadays, encryption is everywhere. But previous generations, they probably didn't encrypt not even one thing throughout their life. In the 80s, internet was not a thing. But email was starting to appear and was more and more common. So email was a perfect fit for RSA. When you send an email, you probably want just the recipient of that email to be able to read the message. Or if you don't want to obfuscate the message, maybe you want the recipient just to know that you were the person that actually wrote and sent that message. So, as I said, email was the perfect fit for this technology. The problem is that algorithms, RSA, or any algorithm for the fact, they're useless without a piece of software that can implement it. So here comes another scientist to our story. The brave Dr. Zimmerman, in 1991, he invented a piece of software that basically implemented this asymmetric cryptography, in particular RSA. He created a piece of software that he called PGP, Pretty Good Privacy. And everybody was super happy because it was the first time that anybody could access this revolutionary asymmetric technology. But there was someone in particular that was not very happy, and that was the American government. At that moment, some encryption technologies that had actually more than 40 bits of security were considered weapons, like military technology. So distributing PGP around the world was considered a crime. In 1993, Zimmerman actually became the target of a criminal investigation by the American government. But luckily, Zimmerman with the help of some colleagues and, of course, lawyers, came up with a way out. They created a book, a physical book, that had the source code of PGP. Before that, the Supreme Court in America had ruled that books and exporting books was completely protected by the First Amendment. So by creating this physical book with the source code of PGP, they were able to distribute it around the world. And actually, the book was published in 1995, and by 1996, all the charges were discharged. PGP was, at that time, it was open source. Everybody was using it. It really enabled a lot of people to access this amazing asymmetric technology. But that was not enough to protect it from the attempt of a government to basically kill it and keep it out of sight. And I know that this story might sound funny mainly because of the book thing, you know? But I think that we all can see where the problem is coming. I don't know if you remember, but there was a company called Netscape Communication that it was a key innovator at the beginning of the web era. Netscape Communication created something. In 1994, they came up with this idea of using asymmetric encryption to protect, encrypt web traffic, and also certify the source of it. The problem is that to do that, they were using encryption algorithms, in particular RSA, as I said. And that was also target of regulation for the American government. Netscape basically put the S in HTTPS. Before this, any kind of communication between a user and a web server was just plain text. So basically, anybody could access it and intercept it. There was no way of sending card information to a web server without being in risk. Netscape changed this. Imagine that Amazon launched in 1995, and this technology was invented in 1994. But as I said, it was regulated by this American regulation for exports of cryptographic technologies. The government forced Netscape Corporation to release two different binary files of the browser. One was targeting the American public, and the other one, the rest of the world. The difference between those versions was basically that the version for the rest of the world had a much weaker cryptography technology. They used RSA with a 40 bits security. And imagine that the PGP, the software that I mentioned before, the one that got traveled to Zimmerman, had at least 128 bits of technology. Of course, it was a company, so they didn't try to do the book trick here. And actually, it was closed source, so there was no way of doing that. But the company was forced to distribute a non-secure version of the browser to the rest of the world. One can say, well, but don't worry, right? Because Netscape at some point was acquired by American Online. And at some point, what they had invented, HTTPS, became an internet standard. And actually, US export regulations changed, so now you can export any kind of cryptographic technology of many, many, many bits. So, and now, probably nobody really remember what American Online was. So we can say everything should be fine, right? No, nothing to worry about right now. During the 80s and the 90s, public key cryptography, and particularly asymmetric encryption, really changed the already revolutionary revolution of digital communications. And nowadays, mainly applied cryptography is circled around what we call privacy-enhancing technologies, PETs. We call them PETs. And probably you have heard some of these names: zero-knowledge proof, multi-party computation, MPC, fully homomorphic encryption. We are already seeing the impact of these new privacy-enhancing technologies in the world. Mainly, I mean, in the blockchain industry, they've been around for a few years. We have the Midnight example, for instance. But we're also starting to see examples in traditional Web 2. I'll invite you to check what Google is doing with zero-knowledge proofs and the new European Union age verification regulation. It's quite interesting. So, as a computer scientist, and I consider myself a technologist, I have no doubt that these new privacy-enhancing technologies are, again, going to change the digital world as we know it. But moving forward, I believe that we must assure that these pets, this privacy-enhancing technology, actually enhance the technology of we, the users. And also, we should try to ensure that it is accessible for anybody. Anybody that wants to use it, of course. We can assume that with high likelihood, somebody is going to try to either stop the development, stop the distribution of this technology, or maybe is going to try to make it weaker or even make it completely useless. What we must never forget is that privacy is a right, and enhancing privacy, should always be something on our mind. I know that nowadays it's kind of more frequent to listen to this argument of, if you don't have anything to hide, you just should show up everything you got. And of course, this is something that we should not accept. Privacy and the tools, the technical tools that allow it, should be protected common goods. Because otherwise, I believe, there won't be privacy at all. So thank you all, and see you around.
Thank you very much.